What's up, everybody? This tutorial is going to cover the significance test for P1 minus P2. I'll sometimes refer to it as the z-test for P1 minus P2. So I'm going to run through the four-step process associated with this type of test, and then I will apply that process to an example. All right, so we're going to start with step one. Step one, you're going to define your parameters of interest. So you have two parameters. You have P1 and P2. So these are both population parameters, so it's important to identify which one stands for which population, basically. After you do that, you're going to write some hypotheses. So your hypotheses always come in pairs. You're going to start with your null hypothesis. This will almost always be your null hypothesis. P1 minus P2 equals 0. So you're assuming the null is true. So we're assuming that your two proportions are equal to 0, which means that your two proportions you're assuming are the same. Your alternate hypothesis then is also, we'll start with P1 minus P2, but now your choices are either greater than 0. So if you reach that conclusion, you're saying P1 is bigger than P2, less than 0, so that P1 is less than P2, or not equal to 0. So you're basically just showing that they're a difference. So this one is called a upper-tailed test. This is a lower-tailed test. This is a two-tailed test. All right, so after you write your hypotheses, you're going to verify your conditions. So basically 3 sets of conditions. You have the random condition, so both samples need to be random. So if you're running an observational study, this will usually mean that your 2 samples were randomly obtained. If you're doing an experiment, usually means that your treatments are randomly assigned to your groups, or your groups randomly assigned to the treatments. Okay, second set of conditions is about a normal sampling distribution. So there's 4 numbers you have to check: n1 times p hat 1, n1 times 1 minus p hat 1, n2 times p hat 2, and n2 times 1 minus p hat 2. Again, all of those need to be greater than or equal to 10. The third condition is the independence condition. Samples must be no more than 10% of their populations. This is done usually because you are sampling without replacement. So this condition will ensure independent sampling. Then so basically once you've verified your conditions, then you want to write down what procedure you're going to do. So you can write a statement something like, since these conditions are met, a 2-sample z-test for P1 minus P2 can be performed. All right, that's step 2. Step 3 is we're actually going to carry out the procedure. So I usually start by drawing the sampling distribution. You want to calculate a test statistic, which in this case will be z. So to calculate z in this case, you're doing p hat 1 minus p hat 2. So that's the difference in your 2 sample proportions. You're going to subtract P1 minus P2. That's going to be the hypothesized difference between your 2 population proportions. This is your null hypothesis basically, and this is usually going to be 0. So your null hypothesis, since that difference is almost always 0, that part of the formula is 0. And then we're going to divide by our standard error. So let's think about our standard error a little bit. So we would like to use the following for our standard error. So square root of P1 times 1 minus P1 over N1 plus P2 times 1 minus P2 over N2. The problem with this is that we don't know P1 or P2. So what we've done with an interval is we just replace P with P hat in all of those places. But what we don't want to do is we don't want to use different values for P1 and P2 because our null hypothesis told us that they were the same. So since we hypothesized that P1 was equal to P2, we don't want to use different values in our standard error formula. So what we're going to do instead is we're going to calculate a new thing called a pooled proportion. So we're going to use a statistic called a pooled or a combined sample proportion to estimate both P1 and P2 in the standard error formula. So this often gets notated as P hat sub C. Sorry, I missed the hat here, where the C stands for combined. And all you do is you basically just take your two samples and you put them together to make one big sample. So on the bottom of the fraction, you're going to add your two sample sizes. On the top of the fraction, you're going to add basically the number of successes that you had in each sample. So that's what this x1 and x2, those are basically what you divide by n to get your proportion. So a quick way of getting x1 is just to take n1 times p hat 1. So then x2 is just n2 times p hat 2. And basically, if you've been working on your 4-step process, that's these two numbers here that you calculated in step 2. All right, so once you have that standard, once you've calculated your pooled proportion, then you're just going to replace basically all of those p's in the standard error formula with that pooled proportion. All right, so once you then have a z-score, you're going to calculate a p-value. If you're using the TI calculator, you're going to use the normal CDF function. Then when you get to step 4, this is where you're going to compare that p-value to your alpha value and decide if you're going to reject the null or fail to reject the null. If you reject the null, you want to say that there is significant evidence to conclude a difference in the true population proportions. And of course, that's going to be in context. If you fail to reject, you're then going to say there's not significant evidence to conclude a difference in the true population proportions. So step 4, it's important to get that interpretation correct. All right, so we're now going to apply that 4-step process to an example. All right, so the example reads, smartest people often dumbest about sunburns is the headline of an article that appeared in the San Luis Obispo Tribune, July 19th, which happens to be my birthday, in the year 2006. The article stated that those with a college degree reported a higher incidence of sunburn than those without a high school degree, 43% versus 25%. For purposes of this exercise, suppose that these percentages were based on random samples of size 200 from each of the two groups of interest, college graduates and then those without a high school degree. Is there convincing evidence that the proportion experiencing a sunburn is higher for the college graduates than it is for those without a high school degree? Answer based on, so we're going to answer this based on a test with a 0.05 significance level. All right, so we can see that there is a difference in the two sample proportions, so about an 18 percentage point difference. So we want to know, is that difference significant enough to conclude that the population proportions are actually different? So that's what the whole point of this significance test is. All right, so what I'm going to do is I'm going to notate some of the numbers all the numbers that were given to me here, and then I'm going to start my process. So I'm going to start with P hat 1, that's going to be this 0.43, P hat 2, 0.25. I usually pick the proportion that's largest to be my first proportion, and that'll save me some like negative numbers down the road. So I'm also going to notate N1, which is 200, N2, which is 200, and then I also know that my alpha value is going to be 0.05. So I like to just notate all that stuff before I start my steps. All right, so then step 1, I'm going to define my parameters of interest. So my first parameter is P1. So P1 is going to be the true proportion of college grads who experience sunburn. And P2 is the true proportion of those without a high school degree who experienced sunburn. All right, so now that I have defined those two parameters, I can write my hypotheses. So I'm going to start with my null. My null is that these two proportions are the same. So P1 minus P2 is equal to 0. So that is what I'm going to be assuming to be true throughout the test. My alternate, I'm going to start the same way. So P1 minus P2. But now again, what I'm trying to show is I'm trying to show that the incidence of sunburn is higher for college graduates. So if I want to do that, and I don't want that to be an equal there. I want that to be a greater than, so it's going to be greater than 0. So I'm trying to show that P1 is greater than P2 so that I get a positive difference if I subtract those two. All right, so step 2 is now my conditions. So I want to check for randomness. So I do have random samples. So I'm just going to note that. So both samples are random. Excuse me. Then I'm going to calculate my numbers. So N1 times P hat 1, 200 times 0.43, that is 86, that is greater than 10. I'm going to do N1 times 1 minus P hat 1, that's 200 times 0.25, which is 50, that is greater than 10. Then I'm going to do the same thing for the second sample. Oops, and I'm sorry. This is my second sample here. So N2 times 1 minus. All right, let me rewrite that here. I'm sorry. So this calculation was N2 P hat 2. So my second sample size times my second sample proportion. Sorry about that. All right, so then now I want to do N1 times 1 minus P hat 1. And then I'm also going to do N2 times 1 minus P hat 2. All right, so this is 200 times 1 minus 0.43, and this is 200 times 1 minus 0.25. All right, I think I got that all straightened out. So that's 114 greater than 10. This is 150 greater than 10. All right. Yeah, those look all right. Okay, so all those are greater than 10, so that will indicate that I have a normal sampling distribution. And now I want to think about the independence condition so that my samples are no more than 10% of the population. So my sample sizes, again, were 200. So if that were exactly 10%, my population size would be 2,000. So is it reasonable to assume that there's more than 2,000 people with a college degree? Yes. Is it reasonable to conclude that more than 2,000 people do not have a high school degree? Also yes. So what we'll just write for that is it is reasonable to conclude that both samples are less than 10% of their populations. All right. So that is the condition. So now I just want to name my procedure. Let's move over here. So we could say is the conditions for a z-test for P1 minus P2 are met. All right, step 2 is done. Step 3, I usually like to just start with my picture. All right, so again, normal sampling distribution. This is going to be my p hat 1 minus p hat 2 axis. That's going to get centered at my null hypothesis, which is 0. So if I assume the two populations are the same, I would assume that that would be centered at, that the difference of my two samples would be centered at that value as well. All right, so then what I want to do is I want to mark off a few standard deviations in each direction. So now what I need to do is I need to calculate that standard error, but before I do that, I need to calculate my pooled proportion, or my combined sample proportion. So I know that I'm going to have two samples of 200, so now I'm going to divide by 400, and then the top again is x1 plus x2. So it's the number of successes divided by the sample size that gives you your sample proportion. So these numbers are going to be, so for 0.43 it was 86 out of 200 gives me 0.43, and 50 out of 200 gives me that 0.25. So then if I calculate that pooled proportion is going to be 0.34. So 0.34, 34% of both samples combined experienced sunburn. All right, so now what I can do is I can calculate my standard error using that pooled proportion. So I'm going to take 0.34 times 1 minus 0.34 over 200 and add that to really the same thing. And these two fractions are the same because our sample sizes happen to be the same. It's not always going to work out like that. Put that all into your calculator. You should get a standard error of about 0.047. So that's what I'm going to count by now on my picture. Oops. 0.047, 0.094, 0.142. Okay, going backwards, pretty easy. It's just going to be the negatives of those. All right, so if I got a difference like this, that would mean my second. If the difference was negative, that would mean my second sample proportion was bigger than my first. Okay, so now what I want to do is I want to put the difference of the two sample proportions that I got in this study on this picture. So remember at the beginning we said there was about an 18% difference, and that's what goes on this picture. So p hat 1 minus p hat 2 is 0.18. That's about here. All right, so now what I want to do is I want to calculate a z-score for that number and then use that to calculate a p-value. Since this is an upper-tailed test, I'm going to be shading this way on my picture. All right, so I want to calculate a z-score now. So my z-score is the difference of my proportions minus 0. And it's 0 because that's my null hypothesis. That's what I'm hypothesizing the difference to be of my two population proportions. All right, and then I'm going to divide by that standard error that I got, and I end up with a z-score that will round up to about 3.8. All right, so that's my z-score. And now what I need is a p-value. So the p-value, will come from normal CDF on the TI calculator. So what I put into normal CDF is my lower boundary. So this is an upper tailed test, I put in my lower boundary, so the z-score of 3.8, and then it's unbounded on the top, so I'm going to put in 1E99, which gives me a really large number that's going to represent positive infinity, and that's going to output a p-value of 7. So this is in scientific notation, 7.24 times 10 to the negative fifth. So a pretty small p-value. All right, so then step 4, I'm going to wrap everything up. So my p-value of 7.24 times 10 to the negative fifth is less than my alpha value of 0.25. So my conclusion here is going to be to reject the null. So I'm going to reject that my two population proportions are the same, which gives me evidence then that the first proportion is bigger than the second proportion. So I'm going to write that in context. So I'm going to say there is significant evidence to conclude that the proportion of those experiencing sunburn is higher for college grads than those without a high school degree. All right, so again, then there is evidence to conclude that that incidence of sunburn is higher for the college grads than for those without the high school degree. All right, then the only thing that I also wanted to show you here, the last thing I wanted to show you here is how you can use your calculator a little bit more efficiently to do this step 3. So I'm going to go to my TI calculator here, and I'm going to use so I'm going to go to hit the stat button, and I'm going to go over to the test menu, and I'm going to select 2PROP-Z test. I'm going to hit enter. I already have the numbers in here, but what I'm going to put in, what it prompts you for is x1, n1, x2, and n2. It's the same numbers you used when you calculated your pooled proportion. So you just type those in. One thing you have to remember is that you can never put in a decimal value. So sometimes when you calculate x1 and n1, if you're using a rounded sample proportion, it's going to give you a decimal value for x1 or x2. That's not allowed in this screen, so you just have to do some rounding to make sure that you're putting in whole numbers. All right, and then you need, down here, you have to pick what type of test you're doing. So we are doing an upper tailed test, so keep that on greater than. Then you have two options, calculate and draw. I usually just go to the calculate screen. You can see up at the top, it gives you the z-score. It gives you the p-value, so just notes it as p. I usually write it down as p-value. Gives you p-hat1, p-hat2. This where it just says p-hat, that's your pooled proportion, so your calculator will actually give you that as well. And then it'll give you back the 2 sample sizes. All right, so that's your 4-step process applied to an example. So yeah, good luck, and thanks for watching.